Hello, everyone, and welcome to today's webinar on the economics of regenerative soil health systems for cotton. The Soil Health Institute is a 501c3 nonprofit organization whose mission is to safeguard and enhance the vitality and productivity of soils through scientific research and advancement. We are very excited about today's webinar, which is the first of several webinars detailing the economics of soil health systems in cotton. This webinar is an outcome of the U.S. Regenerative Cotton Fund, which is an initiative of the Soil Health Institute supported by the Ralph Lauren Corporate Foundation. A recording of today's webinar and the accompanying fact sheet will be sent to all registrants by email and can also be found on the Soil Health Institute's website on the economics page. During the presentation, please type your questions in the Q&A box at the bottom of your screen, and then everyone can upvote those questions. The chat box will be disabled. All questions will be addressed at the end of the presentation. With that, I would like to introduce to you Ms. Yvonne Leahy, VP of Sustainability at Ralph Lauren.
Thank you so much, Latrina. And I'm so happy to be with you all today. Ralph Lauren is a company with a strong connection to cotton, from our dress shirts and denim to our iconic polos. Cotton is by far the most important fiber for our business. And as a company, we are committed to supporting and sourcing more sustainable cotton. And through our corporate foundation's partnership with SHI and the creation of the U.S. Regenerative Cotton Fund, we wanted to further our commitment to a sustainable future for the cotton industry, and specifically investing in the future of U.S. cotton growers. We're so excited about the impact that the adoption of soil health management practices can have, from positive environmental outcomes to improved economic and business outcomes, which we'll talk more about today. This growing body of scientific and economic evidence is really such a powerful tool for accelerating the soil health and regenerative agriculture movement, and we're very proud to support it, learn from it and from all of you, and continue to partner across our industry towards this aim. And with that, I am very happy to introduce our panelists and speaker today. To start, David Lamb. David spearheads soil health training and education programs for the Soil Health Institute's Healthy Soils for Sustainable Cotton. For 40 years, Mr. Lamb served in various positions with USDA NRCS, including district conservationist for the Fort Wayne Field Office, assistant state conservationist for programs in Georgia, and team leader for the National Soil Health and Sustainability Team. He assisted with the USDA NRCS Organic Agriculture and Sustainable Ag effort, and worked with program policy, particularly for the Conservation Security Program. Mr. Lamb earned his BS in Natural Resources from Ball State University in 1978. Dr. Diana Bagnall serves as a research soil scientist for SHI. From 2014 to 2016, she served as a project manager for the AgriLife Research's Corporate Relations Office, developing proposals and managing projects. She managed sponsored research projects in soil and crop science, renewable energy, and agricultural engineering. In 2016, she joined the newly established soil security team at Texas A&M University, composed of soil scientists, economists, and sociologists, where her PhD research received departmental and international recognition. Dr. Bagnall received her MS and PhD in soil science from Texas A&M University. And finally, last but not least, Dr. Archie Flanders. Dr. Flanders is the ag economist at the Soil Health Institute. Dr. Flanders received his BSA in general agriculture and his MS and PhD in agricultural economics from the University of Georgia. His prior research and extension responsibilities in production economics and farm management included development of interactive economic decision tools for crop and livestock commodities, agricultural policy programs, and whole farm analysis, which helped producers customize enterprise budgets to represent unique production situations. As ag economist at the Soil Health Institute, he works with producers and agricultural researchers to develop decision support tools that the farmers and ranchers can use to make informed decisions about production practices on a field-by-field basis, optimizing soil health while realizing economic efficiencies. And with that, David, I will turn it over to you.
Thanks, Devin. I want to take a minute and just kind of introduce our farmer mentors that were selected to part of this economic evaluation, and give you a little background on them. Why were they selected? Well, one, they're a kind of producers that were willing to share their successes and challenges that they've had as they've gone along their soil health journey. Their willingness to answer questions from other producers. They've been farmer mentors with the Soil Health Institute for the last 3 or 4 years and participating in a number of projects, one that was mentioned earlier. They've also been, as a result of this and their willingness to share, and that's one thing about the soil health community, they tend to be very willing to share and help others along the way, along the journey. Maybe they can learn from their mistakes, and these 5 individuals would definitely fit that bill. There's also a number of videos that are on the Institute's home site where they've hosted field days or even sat around. One that's called Cotton and Covers Discussion, where it's just 3 of them sitting around chatting about their experiences with cover crops and reduced tillage. To go along with that, these are producers that have been implementing what we would consider a soil health management system for a number of years, 5, 6, 7 years. A lot of them, several of them have been implementing reduced tillage for more than 15 to 20 years. And as they've kind of evolved from reduced tillage to no-till systems, they've adopted or been using cover crops for a long time. Many of them single species, cereal rye, that type of thing. But in the last 4, 5, 6 years, they've adopted multi-species where they've gotten bold and use 7, 8, maybe even 10 different species. And they've learned how to adjust things along the way to get that. And the other thing, these 5 individuals represent over 15,000 acres of cropland being farmed in the Cotton Belt, ranging from North Carolina across to Texas. So that's not a small amount of acreage. Average, the smallest producer, 800 up to 6,500. So these are bona fide farmers. And you really ask why. Well, what's changed about them? Well, they've really changed their view of how they look at soil. They no longer look at it as basically the physical chemical component, being able to balance the nutrients and till the soil and that type of thing. But they've been able to recognize the role that the soil biology plays in those functions that are necessary for food and fiber production, nutrient cycling, water infiltration. Those types of things are so important to allow us to raise high quality food and fiber. And it's with this experience that they have the confidence to be able to adjust their cropping system down to maybe reduce some inputs, to eliminate tillage operations with a high degree of confidence they're going to have success. And their willingness to share, maybe they haven't been successful all the time, but other times they have, and they're willing to share that. And then this is why they were chosen to be part of this economic analysis, and I don't think we need to downplay the importance of that. While there's only 5 producers, they represent 5 different states within the Cotton Belt, but they also represent these results, this process, this protocol that was followed is supported by other similar studies that the Institute's been part of, and you can get access to that information off of the website. So they've obtained similar results from other crops, but today we're talking about cotton. And one thing is this project, as the U.S. Regenerative Cotton Fund project continues to evolve and roll down the road, so to speak, we are looking for other producers who are willing to share in this experience, to be able to participate and sit through this process that Diana is going to talk about, and help to build that database of success and indicate or the financial viability for adopting soil health management systems. So with that, Diane, I'll turn it over to you to go through the process.
Thank you very much, Dave. That was a great introduction, and I think really hits a couple of the first things that I'd like to do, which is just to thank these producers for sharing their information with us. We really lean on their knowledge of what these systems can be. And so as well, I'd like to take a moment to thank Devin and the Ralph Lauren Corporate Foundation for enabling this work. We really think that this process will allow us to share the value that we found with these farmers with others as well. We've known for a long time that soil health management practices like reducing our tillage and going to cover crops can provide a lot of environmental benefits, things like storing carbon, reducing greenhouse gas emissions. We also know that it can reduce erosion and build drought resilience. And yet our farmers as business people need to answer the question of whether or not these practices make economic sense. And as has been said before, SHI, to help answer that question, interviewed 100 farmers, and we released those results last year. Those farmers were in 9 states, and they were growing primarily corn and soy in Midwestern states. Those studies showed that farmers who use soil health management systems of no-till and cover crops increased their net farm income by $52 per acre for corn and $45 per acre for soybean. And as Archie has said, or Dave has said as well, you can look at the Soil Health Institute website and the economics tab to learn more about that study. But today we're turning our attention to cotton systems. And so as Dave has said, we selected folks, not a random sample, but those folks who really had experience in soil health management systems in cotton. And so I'd again like to thank Dr. Archie Flanders, the agricultural economist who's put together these partial budgets, and thank Dave for his work with these farmers as well. So as we get into our presentation, I want to make sure we're clear on the objective. It is to provide farmers with the economic information that they need when deciding whether to adopt soil health management systems. And we're going to abbreviate that today, SHMS, Soil Health Management System. The approach that we took was that we interviewed these 5 cotton farmers who had adopted soil health management systems for at least 5 years. And as Dave said, many of them have used them quite a bit longer than that. That interview yielded production information, and that allowed Dr. Flanders to calculate partial budgets to compare the costs and benefits of soil health management systems before and after adoption of those soil health management systems. And I want to highlight that in this partial budget approach, we're only looking at the differences between management systems. So we're not going back through receipts and years of yield statistics to get at these data. We can do them in an interview that takes about an hour and a half or so. We know that prices fluctuate over time, and so we've calculated revenue by using a standard set of long-term average prices in this analysis. And the last note here is, while we know that USDA payments for conservation practices are important tools for increasing the adoption of those practices, we did not include them in this analysis because not all farmers use those programs or choose to. And as well, those payments don't last forever. And so this analysis today gives us an idea of how soil health management systems can kind of stand on their own merits. Dave mentioned the different states and production regions. And so here we have a dot representing where the farms were located in Texas, Mississippi, Georgia, South Carolina, and North Carolina. Across this region, the annual rainfall ranged from 19 inches per year to up to 60 inches per year. And as well, the change in temperature annually, the mean annual temperature was between 54 and 68 degrees Fahrenheit. So as Dave said, we are representing a substantial kind of swath here of different production regions. I want to highlight as well the different crops that these farmers were growing. What we're looking here is in the numeric values are the average acres per crop across those 5 farms. So we have cotton, corn, soybean, wheat, peanut, and pink-eyed pea that were in these rotations. But there's 2 numbers I want to highlight. The first is the average total crop acres for the farm. That's at the bottom and bolded, 3,370 acres. So that's the average size of these farms. As well, because we're discussing cotton today, I want to highlight the fact that the average cotton acres across these 5 farms were 1,770. And I read in the Farm Progress Journal that the average size of US cotton farms is about 500 acres. So this indicates that these farmers, having about 3 times that average for the US, are really substantial commercial operations that are making soil health work at scale. Let's talk a little bit now about the particular tillage practices that were in place here, as well as some information on cover crops. What we're looking at in this graphic on the left-hand side at the y-axis, we have percent of planted acres. And then at the bottom on the x-axis, we're looking at 4 different practices: no-till, reduced till, intensive till, and cover crops. And within those practices, we've broken it out so that the green bars represent the 5 farmers that we interviewed. The gold bars represent the average percent of planted acres in each of the 5 states averaged. And then in gray, we have the US average. So if we start there with no-till on the left-hand side, we see that 93% of the planted acres on these 5 farms were using no-till, which is a really impressive value next to an average of only 23% of planted acres in these 5 states that were using no-till. And then nationally, the average is 37%. Of course, because so many of our 5 farmers were using no-till on their practice or on their acreage, we have substantially less reduced tillage there in that second set of bars. Only 5% of those farms were in reduced tillage. Similarly, if we look at intensive tillage, only 2%. So they were not finding it necessary to intensively till very often at all. If we move on to looking at cover crops, this is another impressive number here. We have 79% of the planted acres on these 5 farms in cover crop use. And that's compared to only 8% of planted acres for the 5-state region and 5% for the whole US. So looking at these values, this really echoes what Dave was saying at the beginning and puts some numbers to the fact that these farmers are able to use practices that exemplify soil health management principles, things like keeping living roots in the soil, keeping armor and residue on their soil, and reducing disturbance as much as possible. So I hope these indications about what the 5 farms that we interviewed were like kind of help give us some background as we move into the meat of today's presentation. And what we're going to do now is take a slow walk through the partial budget analysis that Dr. Flanders completed. All the values in this table are in dollars per acre, and each value represents the average of the 5 farms. So let's go ahead and look at broadly the 2 things that we're interested in. One is the way that managing with soil health practices might change our expenses. And so the top set of values there are expense categories, either reduced expenses or additional expenses. If we think about the other change that can happen broadly, it'd be a change in income or revenue. And so there in the center of this table, we have a spot where we're going to calculate the additional or reduced revenue. And then of course, we add together expenses and revenue to come up with a change in net farm income. So to go back to the top and step through this slowly, I first want to highlight with this red box the seed costs that were at play here. So for example, there was an additional expense for these 5 farms on average of $23.60. This is an expense associated with cover crop seed. Now those seed costs for our sample ranged between $20 and $40 per acre. The fact that the average is so close to 20 tells you that these 5 farmers were able to keep, most of them were spending close to $20 an acre for cover crop seed. And all 5 farmers did use cover crops. The next category that I'd like to take a look at is fertilizers and amendments. And for this, I'd like to take a moment and recognize that there's both a reduced expense and an additional expense. That can be a little confusing at first, but it's actually very common that we'll have both a reduced and an additional expense in the same category. So for example, perhaps a farmer is able to cut back on the mineral nitrogen fertilizer that they're applying due to soil health management systems, but perhaps they supplement it by having some manure. That would be both a reduced expense and an additional expense, and they'll be summed together at the end of this process. So we're really looking at, which one was higher and by how much as we march through this table. Specifically, this reduction of $32.33 for fertilizer and amendments is interesting to us. It indicates that these farmers were able to cut back on those additives. And this is really similar to what we've seen in our past data, where we saw that these farmers could reduce the rate of fertilizer that was applied. The reason behind this is straightforward and really backed by science, that as we have better soil health, more soil carbon, we have better nutrient cycling, we have increased water availability and storage, and that's as well going to increase the availability of the nutrients that are present for our crop. These farmers were soil sampling. They were not guessing at how much they could scale back their fertilizer and amendments. And they were passionate about making sure they used the 4 R's of nutrient management. So this is notable because it does represent a substantial reduced expense, but I think it also tells us that soil health management systems and a good nutrient management plan really go hand in hand in these systems. The next category that I want to highlight is a reduction in pesticides on average. So we had a reduction of 21.91 here, so $21.91. And that probably represents things in these operations like not having perhaps to have so much weed control because we have the benefit of cover crops to suppress weeds, but we also have an additional expense in this category that may represent things like cover crop termination. I'd also like to kind of group a couple of items here to highlight. One is fuel and electricity, and the other is labor and services. Both of these categories saw that on the whole, we had reduced expenses. And this is really consistent with what we've seen in the past and what we would expect when we reduce our tillage in these systems. So because we're spending less time on the tractor, we have fewer passes out there, we're able to save on fuel and labor and services. These categories are also noteworthy because, in my mind, they represent not only a reduced expense, but also a benefit in terms of time and in terms of flexibility, because we are reducing the amount of labor and of time spent out in the field. And so they give us those flexibility benefits and time benefits as well as a monetary benefit. And we have a similar narrative here with equipment ownership. When we reduce our tillage, when we're taking fewer passes through the field, we have reduced expenses because we have less wear and tear on our machinery and things just don't wear out as quickly. So at this point, we have marched through really all the expenses, both the reductions and the additional expenses, and we sum those up so that we have in total $119.19 of reduced expenses, as well as $72.13 in additional expenses. And I think it's important to just pause here and note that if we did the math and subtracted $72.13 from $119.19, we'd end up with a value of $47.06 per acre in reduced expenses. I think that just speaks to the fact that even when we don't think about a yield increase, we still have $47 an acre to the benefit in these cotton production systems when we go to soil health management. But the good news is when we looked at additional revenue and interviewed these farmers, we did find that 3 of the 5 reported they had a yield increase associated with soil health management systems. 2 of the 5 said they did not see a yield increase, but they also didn't see a reduction in yield due to soil health management systems. The average yield increase across those 5 farmers was a value of about 80 pounds of lint yield per acre. We multiplied that 80 pounds of lint yield by the long-term average price of 67 cents a pound, and that gives us an additional revenue of $53.60 per acre on average across these 5 farms. And again, because we didn't have anyone reporting reduced yields, we did not have any reduced revenue in this assessment. So when we combined the additional revenue with the reduced expenses, we end up with a value of $172.79 of total benefits. And when we combine the additional expenses with the reduced revenue, which in this case was 0, we have $72.13. Subtracting the 2 of those gives us the net farm income change. And for this case, that is $100.66. So that means that using soil health management systems on average across these 5 farms had a positive change in net farm income of $100.66 per acre. Of course, that's an average across the 5 farms. And so in my next slide, I want to show you a little bit more about the distribution. On the y-axis in this graphic, we have dollars per acre in net farm income. And then we have these bar heights representing the net farm income increase for each of the 5 farms. And you'll see that it ranges from a low of $42 per acre to the highest change in net farm income, which was $190 per acre. So we recognize that all farms are different and there's going to be some variance in exactly what value is calculated. But we were really encouraged to see that no one reported reduced net farm income in response to these soil health management systems. Those that tended to have higher net farm income were those farms in which they did observe that they increased cotton lint yield in response to soil health management system. And as Dave said earlier, we're really excited to expand this work and look at other farms so we can have more data to add to this. I also want to highlight some of the non-economic or non-monetary benefits of soil health management systems. One of those is a reduction in risk. 100% of these farmers said that they increased crop yield resiliency in the face of extreme weather events. So that is something that I think is really notable, that we can reduce our risk by having these soil health management systems in place. As well, 80% said they were able to reduce their fertilizer expenses, as we've chatted about already. Increased field access, 80% said they were able to get out into the field in a more timely manner because of their soil health management systems. And that goes back to this piece about time and flexibility, as well as the monetary benefits. 80% of our farmers said that based on their visual observations of runoff from their field, they believe water quality was improving because of their soil health management systems. And then lastly, we have 60% saying that their soil organic carbon or organic matter was notably increased in their measurements. So in just a moment, I'm going to summarize what we found today, but I wanted to make a note that this fact sheet will be available with all of the information we've talked about today. It will be emailed out, and I believe it's also been dropped in the chat already during today's webinar. Here are some links if you want to learn more about the U.S. Regenerative Cotton Fund, or if you want to see the past economic work that the Soil Health Institute has done. And if you are a cotton producer and you participate in soil health management practices, feel free to email our extension specialist, Mary Griffith, at mgriffith@soilhealthinstitute.org. And we would love to talk to you about the possibility of doing an interview like this, one that information that we've shared with you today. So with that, I'm going to summarize what we found now. The 5 farmers who we interviewed had large farms averaging 3,370 acres, and they used no-till on 93% of those acres, so almost everywhere, and cover crops on 79% of their planted acres. There were no farms that reported decreased yield. 3 of the 5 reported increased yield. It cost an average of $47.06 less to grow cotton using soil health management systems. So that's $47.06 per acre less. Soil health management systems increase net farm income when we account for both the reduction in cost and the increased yield of a total of $100.66 per acre for cotton. Farmers reported additional benefits beyond those monetary ones, such as increased resilience to extreme weather and increased access to their fields. The current adoption rate of no-till is 23% in these 5 states, and for cover crops, it's 8%. And so that tells us that there's a lot of opportunity for other farmers to adopt soil health management practices that will improve their farm profitability as well. And lastly, we're really excited to continue conducting additional economic analysis of cotton systems with soil health management systems as a part of that through the U.S. Regenerative Cotton Fund. With that, I want to thank everyone for taking the time to listen to this presentation. And I'm going to go ahead and turn this meeting back over to Devin as we move into the question and answer period of our day today.
Thank you so much, Diana. Great. We have a number of questions coming into the Q&A. So if you, I think Latrina's been reminding, but instead of putting into the chat, if you can enter into the Q&A, and then we'll see the kind of upvoted questions at the top. So just to start, there's a question about whether the farmers included in the study saw losses in the first years.
Yeah, that's a good question. I think I'll let Archie take that one as he conducted those farmer interviews. But I will remind everyone that we were largely looking at the changes after time. Archie, do you have anything to add to that?
None of the farmers told us that they had losses in the first year, and our data did not include a time horizon. It was the initial circumstance and where they are now. In the future work that we're planning to do, we are going to attempt to collect data to determine what the transition is. But in this sample, none of the farmers reported verbally to us, and we didn't collect that type of data.
Thanks, Archie. Go ahead, David.
Well, I think it's important to keep in mind these systems evolved over time. And, like I mentioned earlier, there are some of them had adopted part of the system 15, 20 years ago, and they started to see changes and benefits. So I don't think any of these 5 just went, last year were conventional farmers. The next year was a soil health management system producer. So I think that's probably why that answer is a little difficult. But I think the key is they saw those changes that Diana mentioned and continued on the process, figuring it out. That's the key.
Great. Another, I think, almost comment question. Are y'all aware of the work by cotton farmer Adam Chappell, who's reported reduced seed cover costs as a major benefit of transitioning to no-till and cover crops?
I think, yeah, we were aware of Adam. Adam was actually one of our farmer mentors in Arkansas during other projects. I think the key to Adam's project, 2 things. Adam's playing around. Actually, Adam's field's behind me right there. That's Adam Chappell Field. And he played around with some wide row cotton, less cotton seed per acre. That was the idea there. And then he's also, and many of these other producers have played around with the volume of seed they're using. They've been able to cut back on the amount of seed that they're using. So that's kind of a twofold question. What Adam's doing, he's using less cover crop seed, and he's playing around with trying to use less cotton seed. So yeah, we're aware of that.
Thanks, David. Another question, did any of the farms have check strips to verify the reduction in fertilizer application, which was not decreasing yield?
No, none of these farms in this sample had check strips. They just, through over time, they can, as they use no-till, and in this case, all cover crops, they determine that they see that they can reduce the amount of fertilizer that they have to apply. With the cover crops, most of them have some legume in the cover crop mix, so they get nitrogen credits from that, so they can cut back with nitrogen applications, but also over time, with nutrient recycling, and they're also able in many cases to reduce phosphorus and potash, but also sometimes lime. As you adopt these soil health management systems, the pH conditions change in the soil, so you can also reduce lime. And they just notice that over time they're not as applying as much as they used to. That's how they made this determination.
Yeah, I hate to keep butting in here, but one of the producers was actually involved with a very group of farmers in South Carolina, and they actually had a farmer-funded research project that they called "How Much Fertilizer Do We Even Need?" or that type of thing. And they had check strips on a neighbor's farm, and they followed that, replicated plot work. So there was some work, not necessarily on his individual farm, but part of a group of farmers in that community. But again, it gets back to having confidence that they saw the system was working. And think, gee, I have the confidence I'm getting more nutrients in the soil profile. I'm not afraid of losing yield because the nutrients are going to be there.
And as Diana said, they're still soil testing, so they know what the conditions of their soil is, so that they're monitoring. They can tell that they don't need to apply as much to have the optimal levels.
Great, thanks. The top upvoted question right now is just that this was an awesome presentation, Dr. Bagnall, so thank you. But the next here is, I think, a really interesting one. Why wouldn't all farmers do this, given the economic benefits? What are the barriers? Go ahead.
Well, I mean, that's the $100 question for sure. I mean, it's something new. You know, it's hard to have confidence in something new. We're familiar with the whole process. We tend to throw the baby out with the bathwater. If we have a problem, we go back to what's comfortable. These producers have said, no, I'm not going to do that. I'm going to figure out, if I have a problem, what the problem is, and continue down this road. They identify because they recognize it's all about the money. You know, they're making money. I think this study documents that. And so they don't go back to the old ways, but it's a challenge. You know, when you think about relying on a biological process that's been there since the dawn of time, to tap into growing cotton or whatever commodity, it's a new thing. And that's why the Institute's there, to help support that science behind it. I think it's just key. That's presentations like Diana gave and Archie put together is just really important.
Yeah, I might add to that we think the regionality is something that, you know, what works someplace just doesn't work everywhere. And that's why we were interested in these 5 states, and why as we go forward, we'll do more locally so that we understand, you know, how the economics as well as the on the ground elements change. And I think that makes it important to not just say, well, we worked in corn and soy in the Midwest, so why won't the cotton, you know, I think that's really something that is a legitimate barrier and something that we want to continue to address.
And a lot of it's how we define success. I'm sorry, Archie, go ahead. I didn't mean to cut you off. Go ahead.
I just wanted to mention one thing. And when you do adopt these systems, it's not a complete overhaul in production, but you do have to make some minor adjustments. For example, if you go to no-till and cover crops, you will need to make some changes in your planting depth, just little things like that. So you do have to have some initial information to get started, but it's not a complete overhaul.
And the other thing is how we define success. You know, everything in agriculture is driven by yield, and I understand commodity programs, support programs, most yield, but just because you grow a lot of product doesn't mean you're making any money. You know, and often, and the emphasis needs to be placed on profitability. How much money am I making per acre, rather than how many bales of cotton or pounds of cotton or whatever, bushels or whatever. But that is a driving factor. It's really hard to separate taking a yield reduction and thinking, well, I can actually make more money because I'm not using as much input. And that's you know, just human nature, I guess.
Yeah, really great points and discussion from all of you. Thank you for that. A more specific question around impact on profit. So when you factor in the cover crop seed cost and the application cost, would that not take away from overall profit? And I think, Danny, you talked about that in that line of the analysis, but maybe just clarifying.
Sure. Yeah, I think that that's why it's important to, of course, add those reduced costs or reduced expenses and together with the additional expenses. And we were really pleased in this case to see that even accounting for the additional expenses associated with a soil health management system, that on average and net, there was a benefit.
Thanks. A question from Dr. Kulver, who's a principal agronomist, PAU in India. So it's about the 93% of area that was under no-till. In that percentage, what were the weed management practices being adopted by farmers, whether it was RR cotton, and which herbicides were used by them? If we have any of that insight.
Well, what we collected would be the changes in herbicide applications. In general, they didn't have to make drastic changes in their weed management systems, oftentimes they're able to reduce one or two applications, or sometimes change to another chemical that might be less expensive than what they were having to apply with conventional till. But they didn't have to make a drastic change in their weed management system to do no-till and cover crops.
And two of these producers, all of them were relying on the cover crop to suppress weeds. It's really hard for a weed to grow up through a nice thick mulch that you kind of see in the picture behind me. But they were also using a roller crimper, to knock the cover crop down, and that helped to terminate the cover crop itself and help create that residue mat. I mean, we're talking, these producers are raising 4, 5, 6 foot tall cover crops. So, I mean, when you're talking that much biomass and then you mush it down with a roller crimper or some kind of a device like that compacts it or lays it on the ground and compact it, that just smothers it out. And so their weed pressures are actually, they'll probably tell you they're less. And as Archie pointed out, they had to make dramatic changes to address any specific outbreak. And we're talking an area of the country that's impacted by these glyphosate resistant weeds that are kind of popping up around the country.
Right. There's a request actually, Dana, to put up the summary slide. I don't know if maybe just for a bit. I know it's hard to have the slides and then all of our faces too, but maybe just for a moment. And a question also for you, Dana, while you're doing that. How did farmers define or better quantify resiliency when responding to the survey questions about changes noticed in resiliency? So what was the definition of resiliency or the quantification of resiliency? Was it subjective or objective?
Yeah, well, I'll let Archie answer the specific question about what was asked in the interview since he was there. But I just want to say, I think we're aware of this desire to have kind of quantitative metrics around things like resilience. But I think that we feel that there's a lot of value in these farmer observations, seeing that it's been adopted at scale and that it's been, really tested over time in the real world. So with that kind of, I guess encouragement to weight very heavily the opinions of these farmers, I'll turn it over to Archie to answer the specific question about that in the interview.
The most common way that was answered was that they can determine that in drought conditions, when they are doing no-till and cover crops, the crop holds up longer before it starts to show signs of deterioration and wilt. That was the primary way they expressed it to us.
Yeah. I can remember one of the producers actually compared his soil health management system and looked at it as an irrigation system. He felt because of what he's adopted, the changes he was seeing, resiliency, water infiltration, increase in organic matter, that he didn't need to, while his neighbors were installing irrigation systems in these coastal plain soils, he didn't feel the need to do that and maintain the yield and profitability that he was looking for. So that's very anecdotal, but that's real world right there.
Great. There's a couple of folks interested in the answer to this question, guessing that none of the farmers were grazing the cover crops, or there would be a line for forage value. Is that an opportunity to boost the value of the system even more from an economic perspective? So if we were to bring grazing into cover crops, and if any of the farmers in the study were doing that, or maybe others that we've looked at?
Yes, it is a way to increase revenue. And one of these farmers did cut the cover crops for forage, and we excluded that because it was a high value on some of the acreage. And so we didn't include that in the table that was presented. But yes, one of these out of the 5 did cut the cover crops for forage. And in our other studies, it's common to either graze or cut the cover crops. I shouldn't say common, it happens. It's from the results that we have, it would look like there would be opportunities that farmers aren't realizing to either graze the cover crops or harvest the cover crops for forage.
Great, thank you. I think another just clarification, explaining again the different tools within the soil health management system, which ones were applied here for the 5 farmers?
Yeah, I think that specifically we were looking at reduced tillage, if I understand the question correctly, and largely in our sample that was no-till, as well as the use of cover crops, and all 5 farmers did use cover crops. They had variety in the particular cover crops that they chose to use.
And this question, I think, was answered a bit earlier, but just to make sure, how many years of data were represented for each farm? For example, are the yield increases they experienced only for 1 year? Like, what was the duration for the data?
The data were collected at the most recent point in time. So with the yield, it would be, the yield right now is, say, 50 pounds greater than what it would be right now if they weren't using no-till and cover crops.
And this is interesting, just sort of thinking beyond the field impact. So will future data address the impact on the overall supply chain, mainly the local economy and supporting services? So the sort of ripple effect that adoption of new practices can have, and if that's something SHI has looked at or would look at in the future.
Yeah, that's a really interesting question. And I think we'd love to be able to quantify that in the long run. The partial budget analysis tool that we're looking at here, I don't think would capture those kind of off-farm changes. But I think that certainly there's a desire, as we see these benefits on farm, to as well look at how that moves through the whole supply chain. I won't say that there are current plans or there's not a plan to quantify that at this time, but it's a good question and something that we care about.
I think, so selling less product, I know that would raise a concern if I was in the agri input business, but things evolve, need to look at opportunities, cover crops. We don't have enough cover crop seed out there to cover all the acres. There's an opportunity to grow cover crop seed. There's an opportunity to become that specialist in your geographical area to supply that, and not just supply that information, but provide the technical support that goes with that. What seed, how do you develop a mix? How do you seed it? What's the best way to terminate it? All that kind of information. So I think as business opportunities, that's a good alternative to spreading fertilizer or providing that kind of thing. So it's more of a positive thing, or could be, than the fact that we're losing less input. And the other thing about the inputs is these are not finite resources. It takes a lot of energy to produce a ton of nitrogen. It takes, we mine phosphorus out of the ground, and those supplies are not infinite. They are limited, and we've gotten the easy stuff, the more challenging. So those are other factors that need to be considered in the overall picture of that cycle that we're going through.
Yeah, it's a great point just about how connected these practices are to larger resource availability and economic factors. There's a comment with a couple of flags on it. David, just your comment about that that no-till soil health management is new. I feel like it's not new, it's actually old, which I think you've also articulated. I think it's potentially not the status quo today is another way to say that. So I think we know you all know we're tapping into practices that it's essentially natural cycles. So yeah, good, agreed, I think is the response there. Any ideas on the cost of changing equipment, planting, fertilizing, et cetera, from conventional to conservation tillage?
The planter is the first one to discuss, and generally a modern planter, the key is to have sufficient downforce. If you do no-till, to get through either no-till residue or through the cover crop, and any modern planter would have that downforce to get through that. And so the only addition for a planter when there is, with maybe coulters and row cleaners, which add about $10 or $12,000 to a typical planter. But some of the farmers that we talk to don't have that, or they've even taken them off. So the planter, a modern planter generally is sufficient for no-till and then planting through no-till, residue, and cover crops. That would be the first consideration in equipment. Then other than that, it's largely reducing equipment instead of adding equipment. Right now, most everybody has a sprayer, a boom sprayer of some type. And if they're not, they're having custom applications of chemicals sprayed. So and the only other thing would be potentially if you want to roller crimp the cover crop, that's about a $30,000 implement to do that. So you could save some expenses with herbicide applications with that and application cost.
So were there any additional methods for reduced tillage? It sounds like some farmers went with full no-till, but did any of the farms use strip till or other reduced tillage methods? And how did those methods maybe compare?
Right. Of these 5 farms, there were no-till, and one was strip till. The strip till would be under reduced tillage. And in this sample, one was strip till, and then with our other sample in the Midwest with corn and soybeans, there were several of those that were strip till, primarily for corn, and then they would no-till the soybeans.
I think it's interesting to note that one of the producers, or 2 of them, have actually eliminated, subsoiling. That's a cost. Archie probably take $40-50 an acre to do that, but because of their systems, adoption of no-till cover crops, they've actually been able to loosen up their soil profile, allow root penetration deeper, and to tap into those resources, and they don't do that anymore. And the only thing I like to tease farmers, the only thing, most farmers are notorious for keeping equipment around forever. You go out to their farm, so equipment savings, they haven't sold what they had, so that's kind of a tough one to evaluate if they don't get rid of things. They're hanger-oners, I guess.
That was one interesting thing that we found out talking to farmers in all our studies. It's commonly thought that you have to till the soil to get it sufficiently pliable and loose to plant so that crops can grow through it. But actually, no-till with cover crops does a better job with that than tilling.
That combination, yeah. The next question, comment, Dr. Bagnall, I appreciate to have a soil scientist here to present this. I understand the higher nutrient availability with improved soil health, but I'm curious if it's truly sustainable to cut your phosphorus and potassium, the P and K inputs long-term.
Yeah, I think that's a good question. And I think that the key is what we were kind of talking about in making sure that we're monitoring the situation, that we look at a site-by-site situation, and that we continue to soil test to make sure that we do have what we need there. So it's not something that I think we would just kind of say, well, just start trying it and see how it goes. I think Dave's experience, having walked across these fields, will be that these farmers have found test results that indicated they could cut back. They've done so, and they've really not seen any negative impacts on their crops. And so that would be the way that I think we would want to go about it in every case, that we start our practices in a measured and sustainable way, and that we make sure we're doing soil testing to see what's there. Dave, do you have any kind of comments?
I couldn't agree. I agree. We need to monitor soil sample, but you got to understand, modern commodity crop production does not produce enough biomass to sustain organic matter. We've lost half our organic matter. Cotton is a very low biomass producing crop, and then we haul most of it off the field. So you think about what's being returned to the soil, not much. So what these producers have done, they're increasing their biomass, which you got roots and shoots, you got stuff above ground, stuff below ground, reproducing and providing that organic matter. And we're talking high volumes, 10, 12,000 pounds of biomass that normally would not be there in a conventional system. That's how they're maintaining their robust nutrient cycle. They're providing that habitat for those soil microbes that are involved with that. So, yes, there is a concern of mining the soil, but when you think about like removing a hay crop, it's got a lot of nutrient value in it. And we're returning all that to the soil. So it's a system that has not been studied enough to make that kind of conclusive proclamation, and I think that's be interesting to look into in the future for sure. Hopefully that makes sense.
Yeah, I think so. A question about, I think it's about organic cotton. And I think maybe the application or what this might look like in organic, and any work that SHI is doing, looking at, soil health management systems in organic.
Yeah, that's a good question. And I believe we have had some organic systems we've looked at. I would say it's something we're really interested in, and particularly if we think about the ability to use cover crops in terms of weed suppression. I think there's just a lot of opportunities that are untapped there. So we do have partnerships with folks who are working on this soil testing on the ground and looking at weeds suppression specifically. And I know I'm really excited to see that work. We think some of it will get started in the next year or two in terms of testing. And then we have had organic farmers included in our samples. And so I'll just throw that back out to Dave and Archie, if you guys have comments of the organic folks we've worked with so far.
Well, there've been very few, but one thing that it seems that any organic system is going to have a perennial cover crop in it. For example, alfalfa that grows for several years to maintain weed suppression and build up soil health through time. Then they come in and plant a crop after the alfalfa. But that's something that as opportunities come up to include more organic producers in our data collection.
Yeah, I think one of the producers, the Texas producer, had a number of acres organic cotton, and his situation again allowed him, because there wasn't necessarily the disease and weed pressures, allowed him to adopt organic cotton a little easier than and low rainfall kind of helped out a little bit too. That rather than someone saying North Carolina where you get 45 inches of rain or something, it makes it a little more challenging.
Great. The next question's for me. So it's asking if Ralph Lauren is adjusting their sourcing strategy to encourage adoption of these practices throughout the supply chain. Yes, we are publicly committed to what we call 100% more sustainable cotton in all of our products by 2025. We define that in sort of a portfolio approach. So we include organic, transitional cotton, better cotton, cotton that's farmed under the Better Cotton system, recycled cotton, which obviously is not farmed, and this emerging space that's maybe called regenerative cotton, or cotton that is farmed under soil health management systems, for which today there are sort of emerging standards and verifications that could enable us to specify to our factories and our mills, kind of all the way up the chain, that we want to bring this cotton into our supply chain. So we already are sourcing more sustainable forms of cotton today in our products, and we are very committed to bringing more, particularly U.S. cotton and U.S. cotton farmed under these kinds of systems into our products. So it's absolutely synced with our sourcing strategy, and both to 2025 and beyond. It's really it's a core part of our sustainability work. And moving back to a question about cover crops, any folks experience germination issues following high residue cover crops?
Nobody expressed that circumstance to us.
There is some concern with certain, like cereal rye, you might have an allelopathic effect. That might be what the question is really about. That's one of those things that you can do and demonstrate in the lab. And I'm all for research. You can demonstrate that in the lab conditions. It's hard to evaluate in underfield conditions. So whether that's, the potential is there, but whether that's reality, I'm not sure. These producers don't seem to be bothered by it. They all plant directly into their cover crops and have great success with germination and plant growth.
Great. And I feel that we are just at time. I think there are a handful of unanswered questions. I think we'll continue to encourage folks to check out the fact sheets that Lutrina is posting in the chat, and encourage conversation and dialogue on this in future webinars and other events. And I'll turn it back over to the SHI team for any closing remarks.
Yeah, thank you so much, Devin. I really appreciated your work here and your partnership. And thanks to everyone for participating. The fact sheet is in the chat if you would like to take a look at it, and likely it will answer some of the questions that you have. If you have more questions, you're welcome to visit our website, or you can email us at info@soilhealthinstitute.org. And with that, I just want to thank everyone for your time and wish you a good day.